The focus for this block of lectures is types and how we represent complex data. We do that by what we call compound types. We're familiar with the basic types in Haskell now. We've seen booleans, characters, integers, ints, floats, and so on. So numeric types, booleans, and characters. We also glancingly talked about strings. And so those things can be used to represent things in the real world, like temperatures or results of choices, or be used to provide text inside a program. But in writing programs, typically what we do is include data that model more complex things. For example, we might model someone's personal details, their address, their date of birth, and so on, as a single item of data. And then, on the basis of that, we might want to build a collection of different people's personal data. So we often want to build collections of individual data items. We might want to represent things like colours or seasons or other things that can be enumerated, a collection of a finite number of different things. Now, we could always do that using integers or whatever, but it would be much better to represent those directly as spring, summer, autumn, and winter, or whatever. And then we get to consider more complicated things like geometrical shapes. We might think that we're dealing with various kinds of geometrical shapes like circles and rectangles and triangles and so on. And each of those will be characterized by a few pieces of data. In the case of a circle, its radius, or if that circle is located in space somewhere, its radius and the position of its center. Whereas a rectangle is represented by its height and width, for example. So different kinds of those things will be represented in different ways. And then we might look at things that are data that is itself recursive. So we might think of a family tree where you start off with ancestors, and each of those ancestors have their own ancestors as they have their own descendants. So the tree either growing downwards will have more descendants in multiple generations, or growing upwards will have ancestors. So quite complicated graphical structures like that. And we also model things which are a bit more abstract, things like the structure that underlies a computer program, or the structure that underlies a computer network. So things that are virtual rather than real, but still need to be modeled in some way. So that's our task, and we'll go some way towards solving that during this block of lectures. But then later on, we'll build on that to describe some more complicated ways of representing data. What we're going to do this week is talk about tuples. And what tuples do first is to take data from different types to build in a fixed shape. That is often called a record in other languages. So, for example, someone's personal data might have an age, a section for age, a section for address, and so on. Whereas typically what we do in Haskell is we represent by lists collections of data from a fixed type. And then crucially and most flexibly, we have in Haskell what are called algebraic types or data types, which allow us to define types for ourselves. So, for example, the type of booleans is a very simple kind of Haskell data type. It just says there are two values in this type, true and false. More complicated types can be built up by constructors. So we can have a constructor circle where, when applied to a float, circle f constructs a shape. So circle of f is a shape when f is a float. And similarly, rectangle, when applied to h and w, two floats, gives us another shape. So a circle will contain one float, its radius. A rectangle will contain two floats, the height and width. So that is a very brief overview of what we'll be going into a lot more detail in the segments to come.